with Avi Loeb, a scientist leading the Galileo Project and an author known for bringing big questions about the universe to the public. He grew up on a farm in Israel, served in the military, and has spent years studying the interstellar visitors like ʻOumuamua and 31 Atlas, asking what the data really says about it, even when the possibilities seem uncomfortable. You can read more about Avi Loeb on our website, 6degrees.blog, or our Instagram page, 6 Degrees Away. Thank you and enjoy the interview.
And I'll edit in an intro, so I won't say right now. I'll just edit one in.
Okay, you will basically put it use the transcript to put in your write-up. Is that?
Yeah. So we typically post the video interview, or we can just do
Ah,
an article if you'd
that
like.
will be perfectly fine. You can use the interview.
Okay, perfect. Thank you so much. So to start, you grew up on a farm in Israel and served in the military before pursuing astrophysics. How did those early experiences shape your curiosity about the universe and your approach to scientific inquiry?
My childhood basically shaped my life because I got connected to nature and appreciated being on my own and thinking about the big questions. I was mostly driven to philosophy, and I'm still very much connected to nature. I jog every morning at sunrise in the company of ducks, bunnies, wild turkeys, and birds, and I see science as the best expression of my love to nature. Because when you love someone, you want to know as much as possible about that someone, and science allows us to learn more about nature. And so that's an expression of my love to nature, the science I'm doing. And I'm trying to address the biggest questions we have. For example, do we have a neighbor? Is there a smarter kid on our block? Is there a sibling to our family of intelligent civilizations? Because this will make a huge impact on the future of humanity. So I'm still maintaining the same approach as I had as a kid. And the other thing is that I didn't become one of those adults in the room that want to show off about what they know and have the arrogance of expertise. I believe that science is more a reflection of the humility to learn, and that's the approach of kids. And you just make mistakes, but it's a process of learning where you figure out reality not by the stories that people tell you or by what experts are saying, but simply by collecting enough data, because it's like a detective story. You get evidence and clues and eventually figure out what the truth is. And it's not up to what you read on the internet or what AI agents tell you. It's more about what nature tells you. But if you do experiments, you collect data with instruments and you figure out things. And so that's a lot of fun as long as you have the humility to learn, as long as you allow yourself to follow the data wherever it leads and not listen to what everyone else is saying. So that's the privilege I have as a scientist, and I'm taking full advantage of it. A lot of people that reach my age become very stiff in their thinking. They stay married to a very specific echo chamber that they developed where they repeat things they already know. And I'm more about learning something new than about things I already know. It's much more exciting.
Hmm. So you've studied multiple interstellar objects, including the Oumuamua and now Three-Eye Atlas. What patterns, if any, do you see across these visitors that differ from solar system objects?
Yeah, so the anomalies that I defined, these are deviations from what we have seen before. They are quite different for the first interstellar object, Oumuamua, which was discovered in 2017, than they are from the latest one, 3A Atlas, the third one that was discovered in 2025. And for Oumuamua, it was the fact that the amount of sunlight reflected from this object, which was roughly the size of a football field, uh, the amount of sunlight changed every 8 hours by a factor of 10. So that means the object was getting extremely bright and then dim and bright and dim every 8 hours as it was rotating. And that meant a very extreme shape, because the amount of sunlight reflected tells us the area of the object that is on the sky. And so that meant that the object is most likely flat, pancake-like, as it was rotating. And that's an unusual shape with a length at least 10 times bigger than its width. And In fact, even if you imagine a piece of paper tumbling in the wind, the area of the piece of paper, I mean, it will never, there will be a very small probability that it will be exactly edge on. And so you see it sideways, and a change by a factor of 10 in the area means that it's really a very unusual object. And then there was also a push of the object away from the sun by some mysterious force, because there wasn't any evaporation, no gas or dust coming off the object. So it wasn't the rocket effect from, the fact that the object recoils by shedding mass in the opposite direction, the way that airplanes do or the way that rockets do. They just shed mass and out of their exhaust, and they get pushed in the opposite direction. There was no evidence for that for Oumuamua, and the question was, what is pushing it? And I suggested it's just a reflection of sunlight. And that meant the object is very thin, and nature doesn't make very thin objects like that. 3 years later, there was another object that was also definitely was pushed by reflecting sunlight, and it ended up being a rocket booster that NASA launched in 1966. And they figured it out because it had a spectrum of stainless steel for its surface. So it's clear that it was made by humans. Anyway, so ʻOumuamua remained a mystery. And then with respect to 3I Atlas, the unusual features are quite different. It's a very massive object, much bigger than ʻOumuamua, but it's moving in the plane of the planets around the sun, so to within 5 degrees. Very unusual arrival direction that has a chance of 1 in 500 by chance. And also, it sheds much more nickel than iron, and the only place where we find nickel without iron is an industrial production of nickel alloys. And there is also an anti-tail, meaning a jet coming from the object in the direction of the sun. And usually we see a tail for comets where there is the gas and dust that are being shed from the comet are pushed away from the sun. And here we don't see that. We see a push towards the sun. And the question is, what's behind it? Why is it so unusual? And it also passed very close to Mars and will pass very close to Jupiter. And the chances of that happening at random, are very small. So these are the anomalies. 3I Atlas is very different from Oumuamua in terms of the deviation from what we expect based on familiar comets.
How does the Galileo Project differ from traditional efforts to search for extraterrestrial intelligence, and what progress has it made?
So the Galileo Project is something that I'm leading for about 3.5 years. And the idea is that the US government admits that they see objects they cannot identify in the sky. They don't know what they are. And of course, they might be produced by adversarial nations, that are spying on the US, for example. But in that case, of course, it's a big national security risk. And we obviously need to figure out these things. But it may also be that some of these objects are not from this Earth, that they were produced by some extraterrestrial civilizations, that some aliens. And to figure it out, the Galileo Project is building observatories that look at the sky and trying to collect new data from observatories that we put together that include a lot of cameras in the infrared, optical, radio, and audio. And we are trying to figure out if there are any objects that are beyond the performance envelope of human-made technologies. And we will collect in the coming year data on millions of objects and try to analyze it with artificial intelligence, machine learning software to figure out if there are any outliers. And in addition, we also had an expedition to the Pacific Ocean to look for the materials of an interstellar meteor to check if it's like Voyager maybe, and this will come out on a Netflix documentary that should come out in 2026. So I encourage everyone to check it and see more details about the Galileo Project there.
Your books, Extraterrestrial and Interstellar, have brought these ideas to a wide audience. What motivated you to write for the public, and how has the response influenced your work?
Yeah, I do think that we need to report to the public because the public funds science. And I call it science of the people. I don't see myself different from the public. I don't see science as an occupation of the elite. I'm not on a pedestal. I'm just like anyone else, trying to figure out things. And I have this privilege of being able to pursue that with scientific tools. And I feel responsible to let the public know what we are doing, and especially on a question the public cares a lot about, like the search for aliens. And in recent months, I received a lot of emails from young people that are very excited and want to become scientists because they heard me speak. And there are so many puzzles and mysteries that we don't understand about the universe that I'm really delighted that your generation, the young generation of today, may be able to do better than my generation did and resolve some of these mysteries. That we really need to figure out the reality that we live in, whether we have neighbors or not. That's an important item on the agenda of science. And we still don't know what most of the universe is made of. We call it dark matter, dark energy. We don't know what it is. We don't know what happened before the Big Bang. We don't know what's inside a black hole. There are lots of fundamental questions. But I think the most consequential one for the future of humanity is whether we have a sibling in our family of intelligent civilizations, and because we can learn much more from their accomplishments. If they have science and technology far more advanced than we have, then we can use it to make much more progress. And everyone is talking about artificial intelligence as being AI and superhuman intelligence in the coming decade, but I see the search for AI also as a search for alien intelligence that might even be more impressive than the artificial intelligence we produce on this earth. So we might be able to learn much more from them.
You face criticism for speculating about extraterrestrial technology. How do you balance bold hypotheses with the rigor of scientific evidence, and what advice would you give young scientists who fear of receiving similar backlash?
Yeah, so my approach is to basically say this is part of science, to allow multiple interpretations, to leave them on the table. And I'm sorry that there are some people who find it difficult to accept the possibility that we might not be the smartest kid on the block. Like, why is that heresy to even imagine that? Why is it difficult for people to consider technological objects that are interstellar objects? Why do we need to insist that they must be icy rocks? Because the point is, we launched equipment to space, and someone else may have done that for millions or billions of years. So we should be open-minded to that. I don't see that as any different from the idea that there is a specific particle that is dark matter and we need to search for it. That is considered completely mainstream. However, the search for technological signatures of interstellar objects, for some reason, was put as a controversial inquiry. I don't think so. And to me, it sounds like common sense to check and consider that possibility, because the implications to humanity are so big. Even if we think a priori that there is a small chance for an interstellar object, to be technological, we should take it serious, because if it ends up being technological, like it could be a black swan event where you think that it's unlikely, but then you figure out that it is the case. And the only way to figure out is by getting as much data as possible. That's the way we learn that we are not at the center of the universe. The Earth moved around the sun for 4.6 billion times before the Vatican even existed. And then the Vatican said no to Galileo, who tried to suggest that maybe the Earth is not at the center of the universe, And then, whether we insist on an idea or not, whether it's popular or not, controversial or not, it's completely irrelevant. The question is, does it describe reality? We can maintain our ignorance by dismissing ideas and not collecting any data and assuming that all the objects in the sky must be rocks, and we will stay that way, like completely ignorant of whether we have a neighbor or not does not depend on whether this idea is popular or controversial. It's completely irrelevant. And we should just be open-minded, and because if we are not open-minded, we will not seek the evidence that will show us that we are wrong. So I think this is the way science should be done. And with respect to young people, of course, there is resistance to thinking outside the box, to being innovative. So young people may be worried about job prospects if they do it early. So I suggest, you don't need to do it necessarily very early. You can, diversify the portfolio on what you're working on and basically show other people that you can solve problems that are considered mainstream and popular. But at the same time, keep those ideas in your back pocket. And once you feel secure that you have a position, that you can explore those on your own, you don't need approval from anyone. Just go ahead and do it, because that's the only way by which we make progress and learn much more, about the directions that we've never thought about before. And I'm very much of the opinion that young people are far more imaginative than old people, because they don't have the baggage of traditional thinking. And I'm trying to keep myself young by doing sports and also thinking like a young person. And I'm working with a lot of young people. I really enjoy that.
Mhm. If we do detect unambiguous evidence of extraterrestrial intelligence, how do you think it would impact human society, philosophy, and religion?
Oh, it will have a huge impact because, well, first, if there is alien technology, there is a potential threat to humanity. And so we should have a warning system that alerts us to any incoming object, whether it's a threat to humanity. I call it planetary defense, but not against rocks, not against the asteroids that we can forecast their trajectory, but against technological objects that could maneuver, and it's more challenging. And I think we will allocate a significant amount of money once the first encounter takes place. We will decide to allocate a fraction of the military budgets worldwide to this subject. And then you will just need to paste the two videos, which shouldn't be too
No,
difficult.
that should be fine. No, that should be.
You will have two files. So,
Mhm.
okay. Um, so let me just continue from where I stopped. Okay.
Okay. So you can start whenever. I'll just edit it to make it look more.
Yeah.
Um, um,
And that, yeah. So let me just, I remember exactly where I stopped. And that may mean that we need to spend about $1 trillion a year on space exploration. That will be a significant fraction of our military budgets right now worldwide, $2.4 trillion a year. And with $1 trillion a year for space exploration, we might actually learn much more about our cosmic neighborhood. So that's as far as science and exploring our neighborhood. But there are also big implications to the way we think about our place in the universe. Because if there is someone far more accomplished than we are not at the top of the food chain. within the Milky Way galaxy, and we might want to get better. So it may change priorities for us. We might decide to explore interstellar space, and since they arrived at our backyard, we might want to arrive at their backyard. And instead of investing all of our resources in conflicts on this rock, we would realize that there is much more real estate than we find on Earth. Earth itself is a tiny rock, 3 millionths of the mass of the sun left over from the formation process of the sun. So there is more to explore far away. And so my hope is it will bring us to a better place. Maybe we'll realize that we are all members of the same species, and we shouldn't fight each other. We should cooperate because we are all in the same boat, and we have a neighbor now, so we should work together and cooperate more. And also it will have religious implications, and we may have thought that we are the only child, I mean, for religious people, the only child of God that exists in terms of a civilization. But if we find other civilizations, we would realize that we have siblings in the family. We are not the only child. And of course, that makes more sense, because why would we think that God is like a parent that can attend to only one child? And it will change a lot of things. We might, even secular people that do not believe in a superhuman entity, they would, that in the past was the realm of traditional religion, that God exists. They may realize that there is someone far more accomplished than the human species, and they would be filled with awe, and that is a new sense for us, because and in the last century or so, we were very proud of ourselves in terms of science and technology, but now we might find that someone else is far better.
As 3i Atlas approaches its closest point to Earth on December 19th, 2025, what key observations do you hope telescopes or ground-based instruments will capture to resolve its nature?
My hope is that we will be able to learn much more about the anti-tail that comes from it, the jets, in particular, the speed of the gas in those jets, whether it can originate from the sublimation of ice, the evaporation of pockets of ice on the surface of a rock, or it may need some technological thrusters to make them. So I think in the coming weeks, we'll get a lot of data from hundreds of observatories around the globe, and also from space telescopes like the Hubble Space Telescope or the Webb Telescope. And this will give us a lot of much needed information. And even if we end up concluding that it's a rock, we might learn quite a lot about this unusual object that would help us when we find new objects in the coming decade. From the Rubin Observatory in Chile, that we expect every few months a new object from interstellar space, and so this frontier should be very exciting, because even if these are rocks, we can in principle land on them, collect materials, and learn whether the building blocks, for example, of life around other stars exist the same way that they existed in the solar system.
Outside of searching for extraterrestrial beings, what has been your favorite work?
My favorite what?
Work that you've done, just more generally about your
career. My favorite work, other than that, was to figure out that, for example, early on in the universe, when the universe was only 15 million years old, the entire universe had room temperature. Because as the universe expands, it gets cooler. But if you go back to when it was only 15 million years old, you won't need to be close to the sun in order to be warmed up. The sun is just a nuclear reactor. It's a furnace that keeps us warm. But if you would have been anywhere in the universe at that time, you would have room temperature. And so that's, I wrote a paper about it. I realized it at Thanksgiving about a decade ago. And it's interesting, if there were any planets back then obviously they could have had life on their surface under these circumstances without being close to a star like we are. But other than that, I also worked a lot about the first stars, the first planets, the first galaxies in the universe, and now we are able to go back in time with the Webb telescope and look at those early galaxies and learn more. And the ideas that I formulated decades ago are being tested, and we learn new things about the early universe. And I also did some work about black holes, which are fascinating because these are the ultimate prisons. If you check in, you can't get out from those. Whatever happens inside a black hole stays there. Just like they say, whatever happens in Vegas stays in Vegas. Um, so black holes are really fascinating. They're extreme structures of space and time. And if I had a very small amount of time left for my life, I might dedicate that time to plunging into a black hole, visiting it, and seeing what's inside. I would love to know that.
And lastly, a question we ask all of our interviewees is, how do you define success personally and professionally?
Oh, for me, it's the sense of satisfaction that I learned something that nobody else figured out about the world, about the universe. And, I don't need to tell it to other people. Like, for example, suppose I were to find evidence for an alien, or there would be a spacecraft that lands in my backyard and they would invite me in. I don't need to report about it on Instagram. It's completely irrelevant for me whether other people know about it. I just want to enjoy it. It's just like climbing the highest, the tallest mountain on earth. You do it just for the challenge. Once you do it, you have an experience that nobody else can understand necessarily. And I would then, find it thrilling to enter a spacecraft and go on a one-way trip away from Earth. I'm very disappointed if I read the news every day. I'm not very happy at what's going on in many places in the world. And having a trip out there to interstellar space would be amazing. I don't need to share it with anyone.
Mhm. So I know I said that was my last question, but what do you think about the whole Occupy Mars movement?
I think going to Mars is not necessarily a great idea for humans. I mean, for scientific purposes, we want to understand, what happened on Mars because it's sort of a twin of the Earth, a little less massive, and life could have started there. It would help us figure out whether life started on Mars and maybe was brought to Earth from Mars. I mean, lots of questions about Mars that are scientifically interesting, but as a place to live on, I would never do it because it's a desert and it's doesn't have an atmosphere. It's really very harsh conditions. The surface temperature changes by hundreds of degrees between day and night. So, it's not a good place to live on. And rather than bringing humans there, I would much rather um, build, invest a lot of funding in building a space platform that can accommodate humans. So, just like we are occupying high rises now in cities, in major cities, instead of living in the jungle and looking for food, now you can order it online. You get the food to your doorstep. And in the same way, we can build an artificial platform that accommodates humans in space. Why rely on a piece of rock that is not really better than Earth? Like this doesn't sound like a good idea for me.
Mhm. Okay, thank you so much for your time. It's been great researching about you and learning more about you, and now obviously meeting you as well.
Well, thanks for having me. It's a great pleasure.
Thanks. I'll send you the edited version. I'll send you
You
the
don't need to. I trust you. You can just make sure that when you put the two videos together, they look seamless.
Okay. We'll
And
do.
good luck. And by the way, you can put it anywhere. I don't know where you're planning to use it.
So we'll send it on our blog, YouTube,
Yeah.
Instagram, Reddit, so all sorts of things. Hopefully it'll get
Okay.
out to a
Yeah,
relatively.
anywhere where you get access to young people, including the social media, TikTok, Instagram, and so forth. That'd
Mhm.
be great. Thank you.
Thank you so much.
Bye bye.